So first we're going to look at all the different words and phrases that mean different things, right? Whether it's addition, whether it's subtraction, whether it's multiplication, division, equals, or parentheses, okay? So these are just some of the words that if you're looking at a word problem would mean these things. And that's going to be important as we go through today. So for right now, we are going to look at page 2 of our notes. So page 2 is this one right here. And all it says is if you are adding and subtracting scientific notation, your exponents have to be equal. Okay, that means that they would have to be in the same tree. So these two are not in the same tree, meaning that you can't add them. These two are in the same tree, meaning you can add them. So they move it so that they get the equal exponents, and then they're able to add that front coefficient, which is the 0.34 and the 4.57, and this is what they get, and then they just do it times 10 to the third. Okay? Multiplication's a little bit easier. It doesn't matter what the numbers in front are. You can multiply them regardless. And then you do your exponent rules. This would be 3 tenths, this would be 4 tenths, for a total of 7 tenths. For the last part, dividing, when numbers in scientific notation are divided, the only number that is divided is this front number. And then this would be 7 tenths, this would be 4 tenths. Cross out your pairs and you are left with 3 tenths. And 9.65 by 1.6 is 6. On the very bottom, if that doesn't make any sense to you, just expand it out. Just make this, if we go back up to the top, make this be 340 plus 4.507, okay? Just add the numbers. Add 4,570 plus 340. You would still get 491. And then we would have 1 0 at the end. And then we can change this back to scientific notation so that it matches this. Okay? We can do the same thing for multiplication. We can change this to 2,000. We can change this to 40,000. Multiply those together, you get 80,000, and then you can change it back to your scientific notation. Okay? Looking at the third page, we're actually going to look at doing some of these operations. So, again, sometimes it's just easier to put it all in standard form. So I'm going to have 1.2 and I'm going to move it 1, 2, 3, 4, and 5. I'm going to add that to 5.35, making that into standard form. So when I add 120,000 and 5,350,000, I get what? Five, 4, 7, 0, 1, 2, 3. My decimal is here. I want it to be here. I realize I'm not writing on the page. So 5.47 times 10 to the 1, 2, 3, 4, 5, and 6. Okay? We could do the same thing with this one. I have 6.91. I move it 1, 2 places to the left. I have 2.4. I move it 1, 2, 3 places to the left. If I add 0.0691 plus 0.0024, I get 0.0715. I want my decimal to be here, meaning it needs to move 2 places. So I have 7.15 times 10 to the negative 2. Okay, so again, if you expand it to be in regular notation or standard notation, and then you just move the decimal back so that it ends up in scientific notation, sometimes that's just the easiest way to do it. Then you don't have to remember all those different rules, and you can just find an example, okay? So I'm going to skip these for right this second, and we are going to look at the bottom. So it says, perform the following operation and express the answer in scientific notation. So this is 4.3 times 10 to the 8th times 2.0 times 10 to the 6th. So for these, I have 4.3 times 2.0 8.60 times 10 to the 14. Right? Or again, you could do, this is 6,000 times, oopsies, it's only 2 places, my bad, 0.015, which equals 90. And I would just move that here. And that'd be 9 times 10 to the first. Okay? It's all about your preference. It's all about your preference. That's all it is. Okay? So if we look at the dividing, same thing. This would be 7.8 divided by 1.2. Which is 6.5. And this would be times 10 to the negative 1. Or you could do 7.8, move it 1, 2, 3, so 78,000 divided by 1, 2, 1, 2, 3, and 4. I can cross out my zeros. 78 divided by 120 is 0.65. Move that 1 to the right. So that becomes 6.5 times 10 to the negative 1. You get the same exact answer. Okay? Again, this might be our best bet, which is perfectly fine. Okay? So let's keep on working on those.